Hi, welcome back to MEEN 221. Today we are going to look at connectors in multiple dimensions. We previously looked at two-dimensional connectors. Now we are going to look at three-dimensional connectors and joints. The ideas are the same, but you have to do a little bit more work. So just to remind ourselves, so when we had two-dimensional objects, we had several kinds of connectors. If you remember, we had a sliding joint, for example. It started out with a welded joint, in which case there were two forces and a moment. A sliding joint had one force and a moment. And if you remember, a pin joint had two forces, and depends upon the situation, we had slight variations, right? So we saw the pin joint, and then we saw the, let me go back. And then we saw the pin slider, that kind of thing, with only one force. And then we saw cables. Cables are extremely useful, and cables have a single force pointing along the bar. We saw all of this, and I'm pretty sure what you did was you just memorized it. I want you to rethink that strategy now, because I think that after a while you have to get higher up in Bloom's taxonomy. You remember what I mean? So rather than memorize it, you should be able to reason your way through it. Okay, this is not hard. What it is that for any joint there will be a certain number of forces, and what a joint does is that in 3 dimensions, out of 6 possible motions. What are the motions? There is the sideways motion, which is called sway. There is the up and down motion, which is called heave. And there is the backward and forth motion like that, which is called surge. And then this is called rolling, and then this is called pitching, and this is called yawing, like that. See what I mean? So those are six different things you can do. Depending upon which of these 6 are prevented, there will be a corresponding force or moment. That's the whole idea. So you got to look through and say, is it preventing surging? Is it preventing swaying? What is it preventing? So that's the whole idea. Okay. Only that load which will be present, which will prevent stuff from happening. Okay. That's how it works. At connections, forget all the other joints and ask what relative motion is prevented by this connection. That's what decides the force. Okay. Now we are going to look at 3-dimensional connectors. Okay. So first thing, as usual, we have a welded joint. A welded joint, as you can see there, is just a welded thing. Now what happens is it prevents all translations and all rotations. So if I weld two things, it will not allow it to do this, 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 it will not allow it to do that. Do you see that? All 6 of them are prevented. So correspondingly, there will be 3 forces which will prevent translations, and 3 torques, the 3 moments along the each axis which prevents rotation. That's a welded joint. All the other joints are special cases of this. That is, if depending upon which of these forces are prevented or added, you will get different things. For example, we are back to a pin joint. In this case, in 3 dimensions, it's called a hinge joint. Can you see? Only one motion is allowed. So that means out of 6 things, 5 will still be present, only 1 is gone. So let us see what motions are gone. The motion, the rotation around this axis is free, so there will be no torque along that. Everything else will still be there. So one way to move plus number of forces present must add up to 6. So can you see? 1, 2, 3, 4, 5 plus one way to move. That's 6. So the number of ways in which it can move is called degree of freedom. So degrees of freedom plus number of constraint forces must add up to 6. That's the idea. Okay. So this is a hinge joint. This is what your door hinge, elbow joints, finger joints, all of these things have this kind of thing. They have 5 different motions and one thing that's allowable. Okay. Okay. That's how it works. Okay. Our next joint is called a Hookean or universal joint. This is actually what is found in your car and other things. So what it is that I'll show you what it looks like. Did you see how those two things work? It will allow you to rotate. It will allow you to change the direction of rotation. This is there in your truck, in the back of your truck, and in all kinds of places. What it is that looks like that. Okay. So what are the motions that are allowed? Let's see. You can do this. One kind of rotation is allowed and another kind of rotation is allowed. Can you see that? There are two kinds of rotation which are allowed. Rotation around the z-axis and rotation around the y-axis if x-axis points towards you. Right? So rotation around the x-axis, rotation around the z-axis are allowed. Everything else is prevented. Okay? So it will prevent all kinds of translational motions because it will not allow you to dislocate this joint. So what are the things that are allowed? Let us see. So rotation around the x-axis is allowed and rotation in this particular case around the y-axis is allowed. So you will see that there are two motions allowed and there are 1, 2, 3, 4 others left. So 2 plus 1, 4 plus 2 is 6. That's how it works. Okay, so that's a Hookean joint. This is not very common, but I want you to understand how the method works. This one is a fairly common thing. This is a ball joint, also like a hip joint. And in this case, you can see that it can spin around itself and it can kind of roll around. So what it is that it has 3 degrees of freedom, 3 different ways in which you can move it, and 1, 2, 3 rotations are allowed, but no translation is allowed. It will prevent you from dislocating your joint. But it will allow all kinds of rotations, this way, this way, this way, all kinds of things. That's a ball joint. So in a ball joint, the corresponding forces will be those Fx, Fy, Fz. Okay. Our next kind of joint is a bearing. Bearing is a very useful thing. It allows shafts to rotate, and what it is that it's a very sophisticated piece of equipment, and one of the best companies that makes bearings is SKF, and you should actually go and see their website. They are one of the best explanations for engineering. They are awesome. I'm going to show you what is inside a bearing. So sorry about the music, but take a look inside the bearing. That's the ball, and all these things are connected together and packed into a bearing. That's how it goes. You see that? Okay, that's a ball bearing. A typical bearing only allows sideways loads. It will allow only those two kinds of things. Perpendicular to the shaft, it does not allow things that to happen parallel to the shaft. That will not allow. If you have things that are parallel to the shaft will kind of pop off the bearing. Not only that, they have to be extremely carefully aligned so that you don't apply moments at the bearing. If there are moments at the bearing, the ball will wear out and you will get jammed. Okay, so typical bearings don't sustain any moments. They only allow forces perpendicular to the shaft. There's one special kind of bearing that allows parallel to the shaft. These things are called thrust bearings or deep groove ball bearings. And what happens there is they will have 3 forces. They will act somewhat like a ball joint. Okay, bearings are some of the most sophisticated things and they are used widely for high speed machinery. Okay, so it's a very important thing to know about them. Okay, and they have to be very carefully aligned to prevent torque. Okay, then what I want you to do is I want you to figure out what are the various things, what are the reaction moments left here. So I will show you what this can do. Do you see that? So you have to now go and figure out what are the moments left here. You should figure it out. It's time for you to stop just trying to memorize stuff and actually think about how these things move. Okay, so that's your job. The last kind of joint that I'm going to look at is a roller joint. A roller joint is actually something that looks like this. So you can see that each ball in this thing there, can you see that ball? Each ball is a joint, right? And you assemble them all together, and it is widely used in conveyor belts and in box handling systems. Can you see how the box can move along in the roller joint? There you go. Do you see that? And what it is that there is a single force. It allows all kinds of other things freely available. So you can rotate it around in different directions. You can rotate it this way, you can rotate it that way. But if there's, each ball provides one force. So if there are n rollers, you will get n forces. That's how you actually get a distributed load on the base of something. What you do is you think of them as these different balls and you sit on them. So this is what is called a roller joint, and this is a very useful thing, widely used in conveyor system. By the way, your roller suitcase works the same way. Okay, take a look at it and you will see that it's equivalent to just applying a perpendicular load, and this is called a roller joint or a free smooth joint. Okay, very good. So we are done. There are a vast number of joints. So let's see. First thing is, hinges are highly restrictive. 5 out of 6 loads are present. Hookean joints, 3 axial force and 1 moment, 4 out of 6. Ball and socket joints, 3 forces and no moments, 3 out of 6. Bearings cannot sustain moments, they will have 2 out of 6. Only thrust bearings can, and they are like ball and sockets. Finally, rolling joints are 1 out of 6. So 5 out of 6, 4 out of 6, 3 out of 6. So let me put this way: 5 out of 6, 4 out of 6 present, 3 out of 6 present, 2 out of 6 present, 1 out of 6 present. That's how it works. Okay, and please remember this major idea that at connections, forget all other joints and ask what relative motion is prevented by this connector. If you have that idea, it's there. By the way, your textbook lists in chapter 5 lists many more joints than the thing that I have given. You should take a look at it, and you should be able to figure out any joint now. You don't have to look up a table. You should just be able to look at the joint and figure out what are the constraint forces possible. Thank you.